Alright, so the second question says find the derivative dy over dx. You can use a calculator to plot the function and derivative to confirm that is correct. So the junior tutor already provided us the plot for using a graphing calculator, so we won't graph it ourselves, but we'll try to find the derivative of this, okay? So the technique that we need to use for this question is the chain rule, okay? Usually the chain rule is written like this. So chain rules are applied to functions that are compositional functions. So there's a function within a function, and as I said in previous lessons, a chain rule can be function within a function within. It can go infinitely. This composition can go infinitely, right? So usually I write the composition of two functions as dy over dx equals dy over du times du over dx. Okay. So this is the chain rule for a composition of two functions. Okay. So we take a variable u and we take that to represent one of our functions, and then we derive dy in base of u and du in base of x, and then by multiplying those together we get our derivative. In this case here we have a compositional of three functions. We have our ln function first, then we have this power within the brackets, and then we have 4x. So actually our compositional function will be this. So we have to set two variables here. So it will be dy over du times du in terms of dv times dv in terms of dx. Okay, so we're going to need to use two substitution variables, and we're going to need to do a chain rule of compositional functions of three. Okay, so let's say let v equal 4x, let u equal v to the power of 7, and let's y equal 7 ln u. Okay, sure. So now if we were to apply our chain rule, right, we have dy over dx equals dy over du, or d of du of 7 ln u, times du over dv, or d of dv of v to the power of 7, and then dv in terms of dx, or d of dx of 4x. Okay, so this is going to equal dy over dx. So we're going to do each of these derivatives. All right, so there's a constant here, but the derivative of ln u is 7 over u, or 1 over u. Okay, derivative of a power function is just using the power rule, so that will equal to 7 v to the power 6. And finally, the derivative of a power of 1 is just the constant itself, so we get 4. Okay, cool. All right, so now we're going to sub u, v, and just u and v back in. Sorry. So u is 4x. V is so we're going to need to sub in v, which is 4x 6. Okay, so wait, let's simplify this first actually. So we'll get 49 times 4, which is 196. So we get 196 v6 over u. Okay. Alright, so u equals v to the power of 7. So we'll have to sub in our u first here. So we get v6 over v7. We can simplify that again, which is 196 over 1 over v. And our v is equal to 4x. So 196 1 over 4x. And in the end, we get 49 over 6x, which is a reciprocal function. Okay, so that is the derivative of 7 ln of 4x to the power of 7. Okay, so it's a reciprocal function, so it's going to be in the blue here, and we see here that as x approaches infinity, the slope decreases, so the rate of change decreases. It's really hard to see in this graph. And when it's approaching negative infinity, the slope decreases, or decreases. Yeah. So this is the correct answer to the solution. So let's just write this is correct answer to solution. Cool. All right.